This video presentation looks at how the teaching of programming can be integrated with other aspects of the primary curriculum. The National Curriculum for Computing aims to ensure that all pupils analyse problems in computational terms and have repeated practical experiences of writing computer programs in order to solve such problems so that they become responsible, competent, confident and creative users of information and communication technology. So, how should programming be taught? Discrete or embedded? As suggested by Berry, there were strong arguments for adopting an embedded approach in the old ICT programme of study, in which ICT was taught in meaningful contexts integrated into other subject areas. Although it will be harder to teach computing in an embedded approach, it is not impossible. There are many opportunities for cross-curricular links in the teaching of programming. These include areas of computational thinking that looks at algorithms and decomposing problems into smaller steps. Berry promotes the importance of this by looking for practical, creative projects that pupils can work on, either individually or with a partner, or as part of a small group. This, after all, is how programming and information technology happens in the real world. So, how can programming support children's learning in other areas across the curriculum? Papert, seen by many as the founder of computing in schools, was a co-developer of the Logo programming language in the late 1960s, and Logo was what influenced Mitch Resnick, a former pupil of Papert, to develop Scratch. The importance of developing children's thinking skills are already well known, researched as well as supported within the national curriculum, and the use of Logo and Scratch are powerful tools to do so. Papert states, "I began to see how children who had learned to program computers could use very concrete computer models to think about thinking and to learn about learning, and in doing so enhance their powers as psychologists." Papert's theory of learning, constructionism, as put simply by Berry, is the theory that people learn best through making things for other people. In terms of online writing, children will learn more and be far more motivated to write for an audience. This is further supported by Berry, who states that pupils learn computer science far more effectively by writing programs to show to others. For example, Scratch helps children with problem-solving skills because they learn from their mistakes and when creating programs and learn to debug them. With all this said, how can a programming tool such as Scratch be used across the curriculum in order to support children's learning? Anne Grayson, a computer science teacher, illustrates how she uses Scratch and incorporates it into the curriculum to develop children's ideas in planning, discussion, questioning, logical and abstract thinking. In science, children learn about forces and energy, and in pairs create an animation of one of the processes. Scratch can also be used in maths by creating an interactive arithmetic game. This is an example of a multiplication game I created myself. It could be made more appealing by adding sprites when getting the answer right or wrong. In French and history, children learn to add audio and animate a story by creating sprites and backgrounds, and then write the scripts. Berry also suggests the following: maths and turtle graphics. The turtle moves with commands that are relative to its own position, such as move forward 10 spaces and turn left 90 degrees. From this, children can learn more complex shapes, like squares, triangles and circles, and explore ideas in geometry. Turtle graphics can also be used with links to art and RE through Islamic art. The geometric patterns of Islamic art can be explored in Scratch, where children design their own interpretations using the turtle graphic commands and pen features. Links with art can be made as Scratch can be used for simple image manipulation. These can be applied using a predetermined script or under the user's control. A disco stimulation and the fish eye and whirl effects can be appealing for the children when manipulating photographs of teachers. The examples given are simply that, examples. There are a host of ways teachers can implement programming across the curriculum, but it is important to remember that the focus is on developing an understanding of programming.